Hi, everyone, and welcome to the last session of the day. My name is Zach Penrod, Sales and Marketing within Motion. Welcome to the session, taking a look at repowering trucks from diesel to electric. It's my pleasure to introduce Chad Burchett, Chief Technology Officer at Trova Commercial Vehicles. Over Chad's career, he has introduced multiple heavy-duty electric trucks to the market. In addition, he has served as a technical advisor for the electrification of various other vehicle use cases. Throughout this session, please utilize the Q&A tab in the top right of your screen so that we can easily track questions and get them answered. And with that, I will turn it over to Chad.
Oh, thanks everybody. Good evening and good late evening, depending on where you're at. And good after lunch if you're here on the East Coast. And good morning if you're on the West Coast. So my name is Chad Burchett, as mentioned by Zach. Thank you for that kind introduction, Zach. I'm the Chief Technology Officer of Trova Commercial Vehicles. Should you need to contact me, my hi, hello information is in the lower left-hand corner, but don't worry, at the end of the presentation, you will see my email address. So if you don't capture it just right now, not a problem. You can always get it at the end. So I want to start off by kind of showing you on a 35,000 foot view what we at Trova see occurring in this industry. We see a third paradigm shift occurring, which hasn't happened in quite some time. We see 4 industry trends transforming the industry by 2030 that will cost upwards of about $2.5 trillion, according to Bank of America and others. These trends are electromobility, connectivity, autonomy, and of course, asset recovery, which is something that in some areas of the world we don't hear a lot about yet. However, you can see a lot of discussion about this in Europe, for example. Now, all these trends will essentially change how things are done when it comes to product development, industrialization models, aftermarket, how companies judge their profitability. And so here we believe that alliances are the tools that will help the new companies come in, and some of the old companies will have to adapt to make sure that they have what it takes to survive in the new industry. So the questions are, who's going to lead this? Who's going to follow? And where is it going to happen? So as far as who's going to lead this, our management team at Trova Commercial Vehicles feels that we are well set to help in this transition. So our CEO and president is Patrick Colleone. He's the former COO of Volvo Americas. And so he was over all the production facilities in North and South America for heavy-duty trucks for the Volvo Group. Myself, Chad Burchett, I was the former EV and autonomous person for Volvo Group in North America, introducing multiple platforms for the Volvo Group, for the Volvo brand, and a technical advisor for a project with the Mack brand. And then, of course, now at Trova as the Chief Technology Officer, helping develop the products that you will see in the later slides. On our board, we have the former president of Mack Trucks, Denny Slagle. And we have other CEOs like Cameron Logistics CEO Colin Peel and Tom Duvall of Truck Movers, which is where you see all the piggyback trucks going down the road. On our advisory board, we have Susan Alt and Russ Tedder, who are former SVPs in the Volvo Group. And we have a European alliance partner that is led by Paul Kegels. He is ex-General Motors, and he is the CEO of eTrova that does what Trova CV does in Europe versus what we do at Trova CV in North America. Our combined experience of the people you see on the slide is 285 years of heavy-duty truck and automotive experience. So we feel we're the ones that can lead this technology shift. Now, where are we going to focus? So we're focusing on the why. And the why is basically we've got an issue out there. Everybody can see that zero-emission trucks are required. There's environmental concerns. For those that don't believe there's an environmental concern, everybody can see that the governments are requesting these changes to be made irregardless, so it really doesn't matter how you feel if you believe it's real or not. There are business advantages to why people would want to go electric, such as fuel costs, maintenance, driver comfort, and retention. So unless you've been hiding in the past couple of weeks, you've probably noticed that the ACT has some serious targets that are going to be adopted not only from California, but in 15 total states in total. And by 2035, as you can see on the slide, Up to 40% of Class 8 truck sales need to be electric vehicles or zero emissions vehicles. That's for tractors. Now, if it's a rigid truck, meaning that it basically has a body mounted to it that's moving goods around, has to be up to 75% of the total market share for zero emissions by 2035. So if you think about the total Class 8 market today, it's roughly about 300 and some thousand units a year. And even to start next year, 5% of that volume is a pretty big number. So we see there's some serious production problems in terms of making the math work. So the problem is multitude. When you think about from an OEM level, OEMs today are having to deal with developing all kinds of combustion engine solutions, whether it's biofuels, hydrogen, LNG, RNG, CNG, you name it. There's a lot out there. But they're also having to keep up with fuel cells and also battery electric. So the difficulty is when you're balancing all these different solutions, how do you hit economies of scale? Due to that is why you see the cost of some of these products being 2 to 3 times that of a standard diesel truck. And then the lead times of these products being 18 months and more in some cases. So with only 1,000 electric vehicles being delivered to date per year, and you've got millions of trucks on the roads, even in just the US, obviously it's like a whale sucking on a Tic Tac. It's just not as noticeable as it needs to be. So at Trova, we believe the solution is repowering those units. So we call it a diesel to electric conversion. What we do, as you see the process on the bottom, we foresee bringing a diesel truck into a truck bay at a dealership or a major carrier, large fleet. And then you pick up the cab, the hood, the bumper, remove it from the original chassis, take the front and rear axles off of the vehicle, and then the internal combustion engine with the after treatment system and the transmission, remove those. You recover 50% of the original vehicle by retaining the front and rear axles, the cab, hood, and bumper. And then you replace the chassis with a skateboard chassis, kind of like what you see up in this right-hand corner. That's our patent pending proprietary chassis system. So it's a skateboard because we want to actually utilize the existing front and rear axles, as you'll see in another slide, for that chassis that already has the powertrain and the batteries with the proprietary software, high voltage driveline in that skateboard chassis. And this is obviously a very new industrial process and a new business enterprise model. So the end result, once you transfer all these components over to the skateboard chassis, within 48 working hours, or roughly about a week and a half in a dealership bay, and for about 50% less cost, you can have an electric truck come out the bay of that dealership. And this significantly reduces the lead time when you think about if it's 18 plus months, our lead time can be as short as up to 3 months from the order to when you can actually have the truck coming out of the other side of the bay. And obviously the cost being less is more attractive. When you look at the skateboard chassis in more detail, this is just an example. So here I'm getting down sort of the 35,000 foot view. We're diving down into the nuts and the bolts of what does this skateboard chassis actually look like. As I mentioned earlier, we carry over some parts from the original truck. And as you see here, the front suspension, front axle, and all the wheel equipment, and the steering gear and the steering system will actually transfer from the original donor truck. As one of the options, obviously you can see in the rear, I'm not showing the tandem axles connected to the rear of the chassis, because in this configuration, you can actually have the original frame rails coming through and they can bolt to this actual skateboard chassis. So you can actually cut the original chassis and merge it together with this skateboard platform. We also have another option where we can continue the rails all the way to the back, and you can have your original suspension configuration, which is just more labor for the dealership or fleet to help you with that transition. Now let's take a look at some of the component modules. So when we look at the front end, you'll notice a much, much smaller radiator. We do not need nearly the same size radiator due to the heat rejection from an internal combustion engine. So your radiator starts up front on this cradle assembly, And in here, you've got like the battery management system. You've got the vehicle's air tanks, air reservoirs. You've got the 12-volt battery, coolant pump, and basically your powertrain ECUs all integrated in here with onboard chargers, DC converters, things of that nature. So when you come around the truck, you'll notice that there's also what we call a junction module over here. Cab entry steps are very simple. It's just basically having brackets. We freed up the side of the chassis where really, we can have auxiliary air tanks in that location, but in most cases it will be unnecessary. So your cab steps, just simple brackets. When it comes to the junction module, here you'll have your high voltage junction box, your drivetrain inverters. Your onboard charger can either be, depending on the configuration, up front, or it can be mounted as part of this junction module, just depending on what we're doing. Your CCS charging plug will be on the back side of this junction module, so it's easy to charge in on the vehicle side, on the left-hand side of the vehicle. That can be changed for other markets, but of course in the US, we're trying to keep the charging plug so it's noticeable by the driver when they ingress and egress the vehicle. And of course your back of cab access steps. As far as the drivetrain goes, it's already actually mounted into a cradle that's part of the skateboard chassis assembly. And the only thing that needs to be connected is the prop shaft or the drive shaft to the rear axles of the vehicle. When you step around to the other side of the vehicle, in this view, it's not so easy to see. We have our auxiliary box, which contains your air compressor, power steering pump, and of course your air dryer. Now, seen in the middle of the chassis is the battery system, which we have here is the energy storage system, the ESS. So this is part of our secret sauce where we're able to package the batteries inside the frame rail with a very unique system that is patent pending on how we do this chassis together with the battery mounting system. So this allows us to use proprietary battery packs, but we can also use a variety of other battery pack manufacturers that are out there today as long as they fit within our module space. And we've already seen that around 5 to 7 different battery pack OEMs we can place their battery components inside of our chassis space. I'll go over a little bit more on specifications on a vehicle level on the next slide. Now, what changes between the different OEMs? Well, obviously you'll have a different cab if it's a different OEM, a different hood, and of course bumper mounts. And of course where your suspension system mounts to. So what we do is we actually have a design. We've already done some prototypes on a Volvo VNR and a Mack Pinnacle. And so what you'll change is basically adapter brackets for mounting the hood, bumper, and the cab to the vehicle. So essentially what this is that you're changing out some of the chassis brackets mounted to the side of the vehicle so that you can actually mount these components so that if you had a PACCAR product with, or it could be a Daimler product, could be a Navistar product. It does not matter with the skateboard platform, which is nice because you can have a lot of commonality among the platform, which gives us economies of scale. And then with some adapter brackets, we can make that original OEM fit and finish. Now, before the vehicles are shipped out, of course, we have to perform the FMVSS testing for that particular model. Once we've done that, of course, it qualifies all the systems as long as the same parts are utilized. So we will do the 121 stop testing or brake testing and the 136 testing with the J-turns for tractors. We go to the next slide. Here you can see our first prototype that we did on a Volvo VNR. When we converted it to electric, you have 2 options. You can or a multitude of options, I should say. You can go as small as 150 kilowatt hour battery pack, and you can go as large as 720 kilowatt hour battery pack. Now, what that gives you for usable energy is from 120 to 576 kilowatt hours of usable energy. The maximum wheel torque capability is well above that of diesel. So of course, for soft start starts, we have derated the output to make sure that you're not roasting the tires off of the vehicle, because that's obviously not working in the operator or the owner's best interest. It does use a 12-volt low voltage system, and the nominal voltage on the high voltage system is around 660 volts. These units, skateboard chassis conversions, are capable of 82,000 pounds gross combination weight. Of course, this could be potentially higher, but we would need to have an option approval from a customer to make sure that we agree to any higher level, because obviously that seriously increases the amount of energy utilized to move that freight. And so we just want to make sure we understand for gradability purposes, making sure you can start as this factory setup is made so that a 16% grade can be attained from a stop. So this means that basically if you're on a exit ramp that is extremely steep, in my opinion, it's possible, but not too probable that you'll end up on something like this. So that gives you a 16% grade to get moving. So we also have at this point in time a 250 kilowatt hour fast charge available as of today. But of course, in the future, as things change, we go to liquid cooled cables, we will obviously increase that as like MCS charging standards start to come into the industry. And this is D2E, so this is a repowered truck solution. This vehicle started its life as a 2016 Volvo, and we also have a Mack Pinnacle that started its life as a 2009 Mack Pinnacle. So as far as age, the target age for a conversion like this could be 3 to 5 years, depending on your trade cycle and your asset utilization and how you want to put the truck to use. But if you want to have an electric vehicle, this gives you an option where you have a much lower cost barrier to enter the industry and utilize your existing asset. As far as weights go, weight is so important to payload. So if you think about what do we have in the works today and what could we have tomorrow with the D2E? So a diesel 6x2 for reference, 14,150 pounds in this case. And an existing industry solution today for 264 kilowatt hours can get you to around 20,500 pounds. That gives you on a total vehicle level about 75 pounds per kilowatt hour of what's on the vehicle. Now, if you want to get a larger configuration, you can get 565 kilowatt hours, and that's going to put you around 24,500 pounds. That improves your efficiency overall to about 43 pounds per kilowatt hour on the vehicle. But when we look at what can happen when you go to the diesel to electric conversion kit, that same vehicle can actually be about on parity with 150 kilowatt hours. So there you come in roughly about the same weight as what you had for diesel. Of course, the overall weight per kilowatt hour is actually not as efficient, but that just keeps in mind that you've got the total vehicle weight with just fewer amount of battery packs. If you go to the maximum size of battery packs available, that would be 720 kilowatt hours, which would get you to roughly 20,600 pounds. And that gives you an efficiency of roughly 29 pounds per kilowatt hour. And as you can see from what's available today on the existing 6x2 in the market, this is almost 4,000 pounds more payload that you can attain with actually more energy on board. So with a 150 kilowatt hour configuration, if you take an industry standard, say 2 kilowatt hours per mile, if you go back to the last slide, for usable energy, that's going to give you, say a 60-mile unit with 2 kilowatt hours of per mile of consumption. Of course, that can be much lower depending on what you're hauling, and it could be a little bit higher depending on what you need to do. But the maximum usable energy that's available would be 576 kilowatt hours. So roughly that's going to get you to about a 275, 300 mile range, depending on what type of use case you have. So if we go into the powertrain, today's electric motors that are utilized for a lot of OEMs are permanent magnet asynchronous motors. And so you'll see a lot of OEMs have different ratings, but of course, some can be 340 continuous with 400 peak. Others can range a little bit more than that. Some can be less than that. So to haul 82,000 pounds, this is roughly about the minimum starting position that I would recommend so that you have good gradability. For the diesel to electric conversion, we have axial flex motors. So if you see the video, hopefully that's coming through, this gives you the potential to have 384 kilowatt hours or kilowatts of continuous power available, with peak demands giving you for at least 30 seconds to a minute, 872 kilowatts of peak power. Now, when you compare this to some of the permanent magnet asynchronous solutions, which might have in some cases for an industry standard component, say 2 kilowatts per liter of space occupied, The axial flux motors utilized on the D2E platform are around 16 kilowatts per liter. So there you're looking at much more efficiency in terms of space and weight utilization. So this is another advantage of why the diesel to electric conversion kits with Trova actually give you a payload benefit and, of course, efficiency optimization as well. So when we talk about use cases in the industry, NACFE does a great job of showing potential use cases with different freights and ranges. And as they show here very, very well, freight payloads that you can expect to see, if it's up to 250 miles of range and 43,000 pounds of payload, battery electric is a good solution as long as you have the right conditions, with asterisks, depending on your charger situation and your routes. You could have other hybrids, that come into place that can kind of bridge that gap and go a little higher. But of course, when you come up to the internal combustion engine and fuel cells, there you can get out to about 650 miles of range and payloads of up to 48,000 pounds. So obviously, batteries, electric vehicles can't fit every use case, and it's not a one-stop solution. It does have its limitations. But of course, at Trova Commercial Vehicles, we are only working with battery electric powertrains so that we can achieve economies of scale. So what kind of vehicle use cases does this fit into? If you take a look at this chart as well, it's very busy, but it gives you a good idea that there are some use cases where within 300 miles, you have a lot of vehicle utilization. For example, yard tractors. As you can see here, up to 100 miles, that covers over 90% of the yard tractor or terminal tractor industry. Then you come out to refuse, for example, up to 150 miles. That covers about 95% of all refuse vehicles that are out there today. Then when you come over to the very far side, you'll see the tractor sleepers. Here you can see that there's a very low percentage of sleeper cabs that actually do less than 300 miles in range. And this is exactly why you will not see a D2E conversion on a majority of tractor sleepers, because you do not have adequate range to do their use case. Now, when it comes to a day cab tractor, this is where the diesel to electric conversion kit can shine. Because when you think about up to 300 miles for the day cabs, well, you hit about 80% of the use cases that are out there today for the day cab tractors for the Class 8 truck market. And of course, there's other use cases that fit in there as well. So when we talk about how much volume of trucks that are being produced out of those 30,000 today, about 75,000 units per year could be repowered with a diesel to electric conversion kit from Trova or others. But of course, when looking at this chart, it makes it hard to say, with the yard tractors being an ideal fit, obviously this is something that should be looked at. And we at Trova agree. That's why we've developed our own e-spotter. So we've got basically the same exact skateboard chassis with obviously some different hole patterns and our own front and rear axles with a liftable fifth wheel mechanism. But we also created our own space frame cab with the bumper and hood. And so what this gives us is a capability, to have up to 208 kilowatt hours of energy per spotter. That gives you 182 kilowatt hours of usable energy. And for most use cases of terminal tractors and spotter trucks on distribution yards or ports, this can give you about 22 hours of operation per day, with driver shifts basically taking their breaks and having opportunity charging in between. So this will fit a large amount of that market every year, which can be 6,000 plus units per year that are made for just yard spotters. Some people might not be familiar with what these trucks do, but they are essentially the backbone of the economy globally. And so it's got plenty of wheel torque for that startability to get these units going. They can handle up to 82,000 pounds with ease. And in some cases, depending on the use case, it can be almost double that, not quite, but of course for option approval, we can always entertain having that. The 12 volt low voltage system, same exact as what you saw in the D2E. And of course the nominal energy, the high voltage system, 660 volts. Here you'll notice that the fast charge is 125 kilowatts, and that's basically due to the battery pack size, so that we don't heat up and overcharge or more heat up the batteries in case they can't handle quite that C rate. So we want to make sure that the batteries have a good life and can give you, say, up to 12 years of age, before in use, before they calendar age out. Now, from a standard use case in a spotter, you could, in some situations, get up to 8 years of life out of your spotter batteries before you need to replace those batteries. And in the worst cases where you're really working these things hard, about 22 hours a day and constantly fast charging and having a lot of mileage, it could be about 6 years until you need to replace your battery packs. But this product is intended to be off-road usage. We will have some DOT versions available as well, but obviously it does not go over 32 miles per hour max speed, considering how these vehicles are used. And this is a new vehicle that we will supply to fill that market need. So that's from a 35,000 foot view down to 1,000 and back to 35,000. So at this point in time, I would like to thank you for your time and listening to us at Trova Commercial Vehicles. And if you have any questions, say maybe after this event, if I have not answered something for you fully, you can email me at chad.burchett@trovacv.com. You can visit our website, which needs to be updated a little bit, but it's at www.trovacv.com. And also feel free to connect with me on LinkedIn. So at this point in time, if we'd like to take any questions, Zach, I'd be more than happy to do so.
All right. Thank you very much, Chad. It was a great walkthrough of your process and technology. We did have a few questions come through. So first, what is the typical cost of a conversion?
Yeah, so the cost essentially depends on the size of your battery packs. So when you think about if you want, say, a minimum range product, let's say you want the 150 kilowatt hour version, there by the time you come to the MSRP, you're looking at around $225,000 prior to incentives. So incentives gets interesting. So with the incentives for the California HVIP program, since this is a repowering, it can in the future qualify for 50% of the HVIP voucher, which gets you to $60,000 per vehicle. Of course, there are federal incentives that can be applied as well, or you could be in New York State, where you have more that can be attained. But you also have to keep in mind with the diesel to electric conversion that in some cases, if you're not taking an incentive that requires the engine be destroyed, you can resell your powertrain. So if you have like a 13-liter engine, for example, in a transmission, you can sell that used engine and transmission in the secondary market to be rebuilt or utilized as is, depending on the mileage. And in some cases, this is no small amount. For an engine alone, for example, for a 13-liter on our donor vehicle, we attained $35,000 from selling the used engine. So depending on your situation, when you look at it, what is the out-of-pocket cost in the end, the net? It can range significantly, but when you think about $225,000 coming down, you can be in a situation where, of course, it costs much less than getting a brand new diesel truck. If you want to get the maximum capacity, say a 300 mile range D2E conversion, then your cost from Trova could be around, say, $285,000 MSRP. But then, of course, you qualify for different incentives from the different states, federal agencies, and potential grants. But then you can also potentially sell the engine. So, of course, it cuts the cost down to where you can actually have it for less than a brand new diesel powertrain vehicle that can cost you, in today's money, around $175,000 for a day cab tractor in today's market. But in the future, after you think about getting to the CARB 2024 or the EPA 2027, where you could have tractor costs of around $250,000, where battery electric actually becomes almost a one-for-one swap when it comes to the cost of a diesel versus the cost of the electric. So we're trying to get the price points to the level with the economies of scale that will improve over time that can be competitive with the diesel with and without grants. And we also have to keep in mind that a brand new electric vehicle today depends on who you talk to, but from some OEMs with a similar level of specification, you can be around $400,000 to $500,000 depending on what you're working with. So this is roughly about half the cost of what you can attain from some other solutions.
Okay, thank you. Next question is if I can maybe rephrase a little bit, what type of charging solution is required for these types of vehicles?
Right, so we have a lot of different options for charging. When it comes to DC fast charging, currently we're offering a CCS1 interface. So there, as I mentioned, you can do up to 250 kilowatts of charging. This means you could go to like an Electrify America station, for example, that's a 350 kilowatt. You plug it in, even though the station might be 350 kilowatt, it will only accept a maximum continuous power of 250 kilowatt to the vehicle itself. Now, we do have AC charging options that we're planning to offer. You have the J1772 standard where you can do AC charging, say overnight or weekend charging, which I would call a trickle charge. That you would do maybe a maximum of the best case scenario, I would say 19 kilowatts. You're not going to get any better than that out of an AC solution J1772. But we also plan to offer a J3068 solution that will give roughly about just shy of, say, 45 kilowatts of AC charging, as long as you have 480 volt three-phase power supplied to the AC charger. So we will have multiple AC charging options available. And of course, those are good use cases when you think about having a lower cost pedestal that's mounted at your facility that already has 480 volt three-phase, and you can accept an overnight charge. For example, if you had 720 kilowatt hours of energy and you had, say, a 45 kilowatt charger, then you can essentially have a full charge from the time you plug it in at the end of your workday, say 5 p.m. to coming starting your shift the next morning. But of course, with a 6 kilowatt J1772 that you might have available at your home, for example, that would obviously take a lot longer. Even an overnight charge wouldn't get you there. But with any DC fast charger out on the market, we do plan to have interoperability testing. So it doesn't matter what type of station you go to. We want to work with the charging manufacturers. And we do have a unique ability at Trova Commercial Vehicles in that we work with Chateau Energy Solutions, who is our partner that helps on the backside with securing the charger, the switchgear, and other things, working with utilities to help get your site set up. They have worked in the U.S. I think most, I'd say 30% of the installations that have occurred in the U.S. at major sites have been handled by Chateau Energy Solutions. So if you have any questions there, I can put you in touch with the right people, and they can help you with your charging needs from soup to nuts. So I hope that answers the question of charger availability, sizes, and some different aspects.
Yep. And then one last one here, and it relates a little bit to the business model of Trova. Are you more of a upfitter and reseller or a contractor in this sense?
So when you think about the spotter trucks, the spotter trucks, we're going to be working with a distributor. So that distributor will work with authorized dealerships to actually sell the terminal tractors or yard spotters to end consumers or fleets. When it comes to the diesel to electric conversion kit, this will be available to fleets, for example, as a direct sale through our channels to them if they have the appropriate facilities and are approved by Trova to do so. But then also we will have authorized dealers that are actually trained to handle the diesel to electric conversion kits, considering that we will offer this for all available OEMs that are out on the market. We will obviously have a multitude of dealerships around the United States, for example, that can take your Peterbilt, Kenworth, Mack, Volvo, Freightliner products and actually convert it to the diesel to electric chassis. So there will be a multitude of dealers, and it'll just be finding the right dealer that's available in your area to do this diesel to electric conversion kit. And I did not mention the timing that we're looking at. As long as we complete our current fundraising, we should be able to achieve start of production by mid next year of 2024 for the spotter trucks. And by the second quarter of 2025, have the diesel to electric kits actually available in production. While this might seem like it's a ways off for everybody, you have to keep in mind if you don't have chargers and infrastructure available to you today, it takes between 18 months and 24 months to actually get your charging stations in place if you're going to do it at a scale. So the time for you to start talking to our partners at Chateau Energy Solutions is now. and also to start planning, because if you don't have the chargers in place, having a electric vehicle doesn't do you a lot of good. So if you begin with the end in mind, I would urge you, if you're seriously contemplating this, making the transition to electric, to start working with someone like Chateau Energy Solutions today, so that when we start our production, you can be one of the first units that come off of our production line and have your conversion done, and then be in your facility and making you money from day one when you receive the truck, and not having to wait on charger installations.
And then I guess one more came in along those lines, Chad. So the expansion of e-trucks depends on charging infrastructure.
Mm-hmm.
So in terms of North America, what is the status today, and how do you expect that to change going forward?
Yeah, right now it's off to what I would say a slow start. When you think about the infrastructure that's out there, a lot of it's meant for automotive use. So if you go to a Electrify America, for example, charging station off the interstate, they do have CCS1 up to 350 kilowatt hour chargers. While it's nice that they're there, of course, they're laid out for you to fit in the parking space. So a lot of the passenger cars are not going to appreciate when a heavy truck pulls in and blocks all the available charging slots so it can charge its batteries. So in those cases, unless you have the charging stations laid out, you're going to have to decouple the trailer from that tractor and then park it in a parking spot and make sure that the charger is able to reach that vehicle to charge it up on those existing charging stations. So we really need more infrastructure built out in the public network, which the federal government and state agencies are working hard to deploy today. And there's a lot of grants out there that are making this happen, working with all kinds of different companies and charger suppliers. But the use case for a lot of what we're working with, the spotter trucks, they're domiciled on site. So typically you're not looking for public charging infrastructure there. You're basically putting your infrastructure in at your own facility. So if you have a distribution yard, you're putting your charger in your distribution yard. If you're at a port, you're putting your chargers in at the port. So you're not dependent upon public charging. When you think about the diesel to electric conversions, where you have, say, up to 300 miles of range with a conversion kit, there you're talking about a lot of return to base operations. So that's actually having charging available at your own site on your terms. There are, as I mentioned, some public charging stations available today on the passenger market. And there are some that are being deployed for the heavy truck space. I know a lot of major truck OEMs are collaborating to try to improve the nationwide network of heavy duty charging. And so you will see that improve over time. But the way we've set up our model with our battery electric vehicles and their range limitations, we see a lot of domiciled units and return to base operations, so that the charging is basically within your control and you're not having to depend about public charging.
Okay. Thank you very much. I think that's the end of the questions here, Chad. Thank you for the good presentation. For everybody else left on the session here, thank you for joining. That's a wrap to the 2023 Future of Electrification Conference. Please keep in mind the videos will be available to you to watch for 30 days after this. You'll probably receive a brief email survey to garner some feedback. And thank you very much for attending this year. We hope you have a great day, and we will see you next year. Thank you very much.
Thanks, everyone.